Uh, well, guys, so today we're gonna present our talk about uh, collecting email addresses and passwords for Exchange server. I don't know how many people here are using Exchange server at their organizations. Yeah, so it's probably will be interesting for you. But we are not trying to hack a server because it's really hard, and we trying to find something to shift it closer to client. So this presentation we presented like 2 months ago on a Black Hat AGA, and it's the second time when we gave it. So I hope it will be interesting for you as well.
So hi, my name is Max, and I'm working for the company here in Bay Area called Shape Security.
My name is Ilya Nesterov, and I also work at a Shape Security, and most time I work on trying to break things or to build things that help me to break other things.
Yeah, I came to Shape Security from Trend Micro, the antivirus company, so where I was working like for a decade. And we're going to talk today about the protocol, which is interesting. And we're going to show you something which will maybe blow your mind, but we'll see. So email, what can be simply the email? So email is quite long. So actually email brought the internet began from the emails, and a lot of people using emails every day, right? And there is nothing really special about emails because it's also researched how the email works, how the delivery works, what the spam is, and we thought we can't find anything interesting over there. And but still, in case of like you use an email and you know how email works, so you know that email is kind of easy to use but kind of difficult to configure. So when you configure your email address, for example, in your phone or in your, some other device, you usually have to know many different things about the email address, like email server, SMTP, POP, IMAP, port, certificate to use, not certificate, and such a thing. So these things usually tricky, and because of that, there is a protocol which called AutoDiscover, which can really makes life easier. And I'm sure that everybody who sits here used this protocol before, but not everybody knows that this protocol exists. I found this protocol for myself when I was doing the open source project called paranoid.email. This is a project for encryption for the emails, so you can, Google it and run this project with Ilya for some time. So, and when I was trying to configure my server to make the life of the users of my project easier, I found out this protocol exists, and I also found out this protocol got a problem. Next slide. So this protocol was announced in 2006 unofficially by Microsoft, and it was just some kind of upcoming feature of the Exchange server. And in 2008, this protocol, next slide, 2008, this protocol was documented and shown as an official protocol on the Microsoft products. So that time, the first documented protocol was released with the .01 version. In 2009, the Thunderbird decided to follow the Microsoft and also delivered the same functionality protocol, which also help users to configure their email address in an easier way. So, and 2010, this protocol was reached and delivered as a part of the protocol called Link Server. So actually Link Server, it's a business part of the Microsoft products, which help the different products exchange information between the products, and also this protocol used a lot now in the Skype. And in 2017, we discovered with Ilya that this protocol got a problem, and we're going to talk about this problem now. Actually, what can be easier than just to use AutoDiscover protocol? So this protocol works in a way like you have a server inside the network, and this server propagate this information inside the network about or outside the network as well, how to configure your client. So basically your client trying to connect to the server, get the configuration file, and this configuration file provide all information around how your client should communicate with the server. So I come up to this idea last year. I mean, I told you about the open source project I'm running, and why I decided to test the auto-discover protocol for vulnerability, because last year I presented on Black Hat USA the speech about the WPAT protocol. So this is almost similar protocol, but this protocol helps just usual user how to configure the proxy settings of your machine. And I found out that this protocol leak into the open internet a lot of information, which is not should not be in this way.
So how After Discover protocol works, there is like two different parts. There is After Discover server and a client. And client, in order to communicate with After Discover server to get settings for email client, basically have to do it in two stages. So it have to define a list of After Discover potential servers and then try to reach each server. And if attempts succeed, then it just get all these settings and use it in a client. So how defining candidate pool works is defined in different ways. So first of all, if you're inside a network and you can reach LDAP or Active Directory servers, so first of all, client will try to contact the servers to get information about After Discover servers. And if it's outside of local network, it will try to derive URLs for After Discover server from email address. And third attempt, it's trying to query DNS server for After Discover SRV record. And if it's all failed, so there is another thing how it can do is just to send an authenticated GET request to URLs that also derived from email address. And then it prioritizes this list, right? So how deriving URL from provided user email address works? So you just enter in your email client email address and a password, and the client have to take the main part of email address and construct two URLs. One URL is contains HTTPS domain derived from email address and a path to After Discover XML file. And another one is constructed by prepending After Discover keyword to domain.
So I just wanted to add here, just to explain, usability here works in this way, like you open your, I don't know, iPhone or Android device, and instead of putting all the information inside your device, like about the SMTP server, everything like IMAP settings, port, you just put your email address and the password and click submit, and usually your device should be configured to connect to the mailbox.
Yeah, right. Yeah, so that's how deriving URL from email address works, right? So nothing interesting, but actually it's pretty simple, right? So you just deriving, you give an email address, you derive a domain part and a local part from it. You can probably come up with different algorithms how to do this, just probably by simply splitting using add character, or just, I know, trying to find this character from forward or from backward position. And that's it. Yeah, what can be wrong with this actually? But if you ever read an RFC about all these mail protocols, there is plenty of them. And this 4 is just probably third iteration. And it has about 30 years of history how to deal with email addresses. So if you can think about valid and invalid email addresses, and you can think about algorithms how you can split given email address to local and domain part. Let's say you do it for using by add characters, but add characters is allowed actually in a local part if you put it in a quote. But if you don't, then it's invalid address. So it's probably enough complexity in a protocol itself, especially that email address used to derive domain names and URLs and basically send requests to them. And when it's really important piece of a protocol when after discover clients send request to after discover URL derived from UML, it is authenticated request. So it means it has an authentication header, depends on which settings server can use. In most cases, it would be just basic authentication. If client ever contacted like LDAP or AD server, it may already know that it has to use an TLM authentication, which will be harder to crack, but in case of basic, it's just like a plain text, base64 encoded. So we decided to just try few different email client, and especially after discover client implementation, to find out whether they work okay or not according to protocol. And we got a list of different valid and invalid email addresses like this, and created a test bed and tried to find some issues. And this is what we found.
First of all, when we tested the list of the non-really standard email addresses for what we thought it can be not really standard for some of the software devices, we found out that in case of you use a Samsung native client for Samsung devices, in case of you use a email address like you see on on the screen, like tomconf77 example.com.au, and you're trying to add this device to the Samsung
Email
address to Samsung device, your Samsung device is going to make two different requests. The first request, actually, this is right, and this is how the AutoDiscover protocol described. So the request will be sent to the domain name, which is derived from the email address, like example.com.au. And the second request will go somehow to the domain name like autodiscover.com.eu, which is wrong, because Samsung somehow misspelled the main part of the email address. We found this problem, and we tested this problem a little bit. So, and we informed Samsung about that, and the Samsung released the patch for this problem in January 2017.
Yeah, and a problem here is if your organization register domain under second level domain, like com.au, com.ua, co.nz, or whatever like this, then someone can register after discover domain under the same second level domain and run HTTP sync servers there and receive all requests from all these vulnerable clients. And all these requests will carry user credentials and email address. So you get it, you get it for free.
Guess who registered this domain name? The second thing, what we found that when we was testing out the magic list of the non-really standard email addresses against the iOS devices, we found out that in case of the to add in an email address exist, so then the iOS device making the wrong request as well. So the calculation of the how many add characters at the email address is wrong by Apple, and basically then the request done to the not to the autodiscover domain name. The request will be done to autodiscover top level to TLD actually.
Yeah, so this email is completely invalid. So first of all, they should not allow user to enter email like this. And what they actually do, so they take a com as their domain part and send a request to autodiscover.com or any other top-level domain, right? When we looked into a list of Mozilla public suffix, and there is about like 8,000 different second-level domains, and IANA TLD list contains about 1.5K domains as well. So it gives us about 10,000 potential after-discovered domains, which you can register, run HTTP sync there to see how big is a problem. And this is what we decided to do, actually. So we decided to register, I don't know, 26 domains and run a simple HTTP server and accept all requests wherever people will send us.
So domains we registered was not really like random. So we predicted that these domain names will have a most impact of this problem.
Yeah, so if you go to, let's say, Shodan and trying to find how many people run after this Exchange server for, let's say, different country, you can easily find these stats to predict which domains will be most useful for this. Yeah, so it's easy to obtain certificates for these domains because it's absolutely legitimate. We don't do anything non-legitimate in this case. And we started to collecting data, and it just basically
it was a bit different way. So actually, Ilya, we registered these domain names. We make up and running our sync service, which was receiving requests, which we expected going to receive requests. And as soon as we registered the first domain name, configured the certificate in the proper way, I think using like a bot cert and whatever. So Ilya called me like at 3 a.m. in the morning saying that, hey Max, we have a traffic. So, and the most difficult thing was
that I really cannot fall asleep after that because I did it like after work. It's probably finished at 3 a.m. And after I just started and I looking into access log of Nginx server, I see like hundreds requests, and it's like more than 10 requests per second from different clients. And you see it's mostly Samsung devices, and I have to scrub all these emails actually, but this is the real emails from real people. So if you want, we would be able to receive passwords from these guys as well, like easily. We just don't need to.
You haven't mentioned one thing. So why he couldn't get sleep? Because when we seen these requests, with requests not only like just simple requests with the email address. In some of the requests, we've seen also encoded passwords as well. So that's the most problem.
Yeah, so we ran this HTTP sync for several months. So we registered 26 domains and received about like 30 million requests. And 70% of all these requests carried users' credentials, username and password. And so it's about 2.5K different user agents affected it. The number is really big because diversity of Samsung Android clients is really huge. So if it's just like one model, like Samsung H7 or whatever, it can be different for different markets like US, UK, Asia, Australia. So it's like one model, but they already have like 5 or 10 different user agents.
As I mentioned before, the Samsung and Apple, they released the patches. So actually Samsung released the patch in January 2017 this year. And patch was, the Samsung was good in communication, so they really told us that they're going to make a patch. They released it. The patch was, updating some of the devices. My main problem with the Samsung, that not all the people making these updates. And we see the traffic up till now. Traffic going a bit lower, so it's not like several requests per second, so it's maybe several dozen requests per minute, but still we see the traffic. So the Apple also released the patch right before our presentation on Black Hat Asia, and the patch was an update of the iPhone 10.3. It was like just a few days before we agreed to disclose it. And for Apple devices, a bit better because we don't see much traffic now from Apple devices because most of the devices, I think, updated with the patch they released.
Yeah, there is more data about like trends and user agents, and you can find it in our white paper. It's published on a Black Hat Asia website. There is like more technical information about all this stuff. So if you want to know more, I suggest you to download it and read. So let's talk a little bit about mitigations, how we can mitigate this thing, right? Accept get patches from different vendors. So first of all, if you're using Samsung devices, you gotta be update to a latest version what they have, because they already patched it, so you will be not vulnerable to this issue. If you are responsible for security in your organization, I better check all email clients you guys using in the similar way to find out whether there is some vulnerabilities, because we didn't check all these clients. There is like not hundreds, but about 100 of different email clients that can work with Exchange Server. And I bet there is much more vulnerable email clients that works in a similar way.
Also, maybe with our research, we haven't seen everything around bad domain names, because we're just only 26. And we did it as independent researchers, so we don't have like a big budget for that. But still, I mean, in case of your enterprise, you can also check your outgoing HTTP logs for the requests to auto-discover domain names, which should not be done to, open internet maybe. So you can determine the clients which are affected by this problem.
Yeah, so, and I've seen there is like a couple of open source implementations of auto-discover client, not for a client itself, but for servers that work as a client for Exchange for a different thing. And we found some of them requesting or sending requests to our sync servers. So if you are developing something like this, it's better to just read all the documentation on Microsoft websites. They have like plenty documentation about auto-discover, how to do it right, how to do it wrong, and they have like their own libraries written in .NET, but you still can use them. And I think we put this recommendation for ICANN to ban auto-discover, new auto-discover domain registration, but I guess nobody will do this as for WPAD. So anyone can go and register from all this like 10 canned domains and see.
No, I mean, communication with the ICANN was kind of successful with WPAD, so I was able to provide the ICANN the idea that this domain collision should be shut down. And most of the WPAD domain names, which I was able to register last year and make use of it to collect several million requests with the traffic from these domain names, was blocked. But about auto-discover is a bit different, because this problem is not as loud as WPAD was last year. And up till now, like, we're working at a startup, and this startup doing a lot of things with credential stuffing, with access credential things. And we always, see the leakages in underground, people talking about how to hack, how to buy the, lists of the email addresses which is stolen. But in most cases, it works like people doing like some kind of phishing or accusing this information via the botnet. But this way, like in case of you just go and you know what kind of domain name you can register, and you can receive login, usernames, email address, usernames, and passwords without any problem. This is, I think, for ourselves, it's kind of a new way how you can, earn money just knowing the domain collision, which can bring you a lot of traffic.
Yeah, so to wrap it up, if you have to work with emails, you have to parse them. Please read documentations. Please read recent RFCs. There have been like 3 iterations about like all these protocols which work with emails, and they cover most of all these edge cases and scenarios. And also follow documentation from vendors. They have a pretty comprehensive documentation, not just like a simple protocol implementation. And yeah, nobody's perfect. We all do mistakes. Let's learn from each other. And thank you. If you guys have any questions, we'll take it after that. Thank you.